In this lesson, we will explore how to effectively work with null values in SQL queries. Null values represent missing or unknown data, and it's important to understand how to handle them correctly to get accurate results from your database. Let's define what a null value actually means in SQL. Null represents the absence of a value or an unknown value in a database field. It is not the same as zero, an empty string, or a space. Here are some key characteristics of null values. Firstly, null is not equal to anything, not even to itself. Secondly, null cannot be compared using standard operators like equals to or not equals to. Thirdly, arithmetic operations with null result in null. And lastly, null requires special handling in queries, which we'll cover in this lesson. To check for null values, we can't use standard comparison operators. Instead, we use the IFNULL and IFNULL operators. Let's explore each of them in more detail with code examples. First up is IFNULL. This operator checks if a value is null. Here is an example query. Select customer_ID, first_name, last_name from customers where email is null. This query will return all customers where the email field is null or empty. Here's another example. Select product_name, price from products where description is null. This will find all products without a description. Next up is IFNULL. This operator checks if a value is not null. Let's look at some example queries. Select employee_ID, first_name, last_name from employees where manager_ID is not null. This query will return all employees who have a manager assigned. In other words, employees whose manager ID is not null. Here's another example. Select customer_ID, full_name from customers where phone is not null. This query will find all customers that have a phone number listed. When dealing with null values in SQL, it's important to understand how they behave in comparisons. SQL uses a three-valued logic system, which includes true, false, and unknown. Let's go over some examples to illustrate this concept. First, null equals null results in unknown, because null cannot be compared for equality. Next, null not equals null also results in unknown, because null cannot be compared for inequality. Column_name equals null will not find rows with null values, it results in unknown. Column_name not equals null will also result in unknown, and will not filter out rows with null values. The correct way to test for null is with column_name is null, which returns either true or false. For null and true, the result is unknown, as null in logical operations can lead to uncertain results. For null or true, the result is true because true dominates in or operations with null. Lastly, null or false results in unknown, because null with false in or operations remains unknown. The COALESCE function is a powerful tool in SQL for handling null values. COALESCE returns the first non-null value in a list of expressions. It's commonly used to substitute null values with the default value. The syntax is as follows. Select COALESCE, expression 1, expression 2, expression 3, and so on. COALESCE evaluates expressions from left to right until finding the first non-null value. Let's look at a couple of examples. Firstly, replace null phone numbers with not applicable, which stands for not applicable. Select customer_ID, first_name, COALESCE phone_number, not applicable as phone from customers. Secondly, calculating commission based on multiple rates. Select order_ID, COALESCE commission_rate, standard_rate, 0.05 times total AS commission from orders. The NULLIF function is another useful tool for handling null values. NULLIF returns null if two expressions are equal. Otherwise, it returns the first expression. The syntax is as follows. Select NULLIF, expression 1, expression 2. Here are some common uses for NULLIF. Firstly, converting specific values to null. Secondly, avoiding division by zero errors. Thirdly, handling special cases in data. Now let's look at some examples. First, convert empty strings to null. Select product_ID, NULLIF description, open and close single quotes as description from products. Next, avoid division by 0. Select total_amount divided by NULLIF total_items, 0 as average item price from orders. Different databases have slightly different functions for handling null values. Let's explore some of these database-specific null functions. First up is IFNULL. IFNULL is used in MySQL to replace null values with the default. Here is an example. Select product_name, IFNULL discount, 0 as discount from products. Next up is NVL. NVL is used in Oracle to replace null commission with 0. Here is an example. Select employee_ID, NVL commission_percentage, 0 as commission from employees. Next is IFNULL. IFNULL is used in SQL Server to replace null phone with unknown. Here is an example. Select customer_name IFNULL phone, unknown as contact from customers. Lastly, a universal way to handle null is the case expression. Here is an example of handling null with case. Select order_ID, case when shipping_date is null, then not shipped else shipped and as ship_status from orders. Aggregate functions behave in specific ways when dealing with null values. It's important to understand these behaviors to ensure the accuracy of your queries. Here's an overview. Count * counts all rows, including those with null values. Count open parenthesis column name close parenthesis counts only non-null values in the specified column. Functions like sum, average, minimum, and maximum ignore null values in their calculations. To illustrate this point, let's say we have these values, 10, 20, null, 30, and null. Count * would return 5 because it's counting all the rows. Count column would return 3 because it's only counting the values that are not null. The sum would be 60. The average would be 20. The minimum would be 10. And the maximum would be 30. Here are some best practices for handling null values in SQL. Firstly, use IFNULL and IFNULL for null checks. Secondly, use the COALESCE function to provide default values. Thirdly, consider database-specific functions when applicable. Fourthly, be aware of null behavior in aggregate functions. Fifthly, use not exists for complex null comparisons. And here are some things to avoid. Firstly, do not use column equals null or column not equals null. Secondly, do not treat null as 0 or an empty string. Thirdly, don't assume null values will be excluded by where clauses. Fourthly, do not use string functions on potentially null columns without handling. And fifthly, avoid unnecessary handling for columns with not null constraint. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.